Hi there, my name is Molly Murnane, and I am working with Daniel Laughlin from the Botany Department, and my project is on the effect of optimizing drought tolerance and invasion resistance on water uptake and nutrient cycling. My project is a branch of a much larger project, and that project is focused on optimizing for drought tolerance and invasion resistance. They're doing this because drought and invasion are huge threats to the Western grasslands that we know and love. And they're trying to use traits, plant traits, to optimize for these desired qualities so that we will see less plants dying due to drought or invasion. But my project comes in because we have to question, are there consequences to optimizing for drought tolerance and invasion resistance? Normally when we optimize for something, it'll decrease the functional diversity, which can have large effects on water uptake or nutrient cycling. So we need to watch this to make sure we're not doing anything really bad when we're optimizing for these things. I guess in general, the project set up in Cheyenne at the High Plains Grassland Research Station. When the experiment was designed, we had a species pool up here at the top, and we would pull 6 graminoids and 9 forbs from this to make a mini community. And then from those groups that we created, we created different assemblages, and each of these assemblages had a certain thing they were optimizing, whether it's drought tolerance, invasion resistance. We had one for functional diversity, to look at those things we were talking about, because we know when we optimize for a certain thing, it will probably lead to a decrease in functional diversity. So we have a assemblage that's just looking at having the maximum functional diversity to see the difference between the two. And then we have a random one. The traits that the large project's looking for, like for instance, for drought tolerance, they're looking for a low turgor loss point, high LDMC, and a max root diameter. These are all traits that would lead to supposedly greater drought tolerance. We have similar traits for invasion resistance, and that's kind of what the project is built off of. There's still stuff that we have to do that we haven't done yet, because most of the things that have been done were weighing out the seeds, tilling, spraying the plots, weeding, watering, building rainout shelters so we can control the water for the drought tolerance, and then measuring the composition of the space. What we still have to do would be to add the invader, which is Bromus tictorum, to the plots. Additionally, we're going to be testing for water use using a leaf parameter. We'll be looking at nutrient cycling in the soil from soil cores, and we sieve those cores to get nitrogen content. And these are pictures from this site. It's really, really gorgeous. I guess the main point of any research is why do we care? Why is this important? And this is really important, like I was mentioning in the beginning, is drought and invasions are major threats to our lands, and especially in Wyoming, where we have like energy use and so many people using land. And when we have to restore it, we want the restoration and our plant communities we develop there to survive. So we would want them to be optimized for drought tolerance and invasion resistance, so they don't fail to survive due to those major threats to the Western grasslands. So, and then when we're looking at this, like the point of my project is when we are optimizing for these traits, which is great because we want our plants to survive, it normally leads to a decrease in functional diversity. And this is not necessarily great because functional diversity is very important. It enhances ecosystem services like productivity, carbon sequestration, and nutrient cycling. which is why we're looking at water use and nutrient cycling, like see how that's affected, which it's just crazy. This is very important, and we have to have a balancing act here to make sure that we want our community to survive, but we don't want to decrease functional diversity so much that the ecosystem services are just failing, which is the point of the project. If you have any questions, just let me know, and I thank you for watching.